So today I was asked a question about how to use Excel in order to work out arc energy in heat inputs. And after explaining this, I decided, well, it might be a good idea just to make a quick video on it for those who don't really use Microsoft Excel to do calculations. It's really quite straightforward, and we'll go through it bit by bit. So the first thing to sort of get down is the calculations we need. So arc energy, the first one, that is amps times volts. So we'll go the other way around. We'll go volts times amps times time divided by our material length, our weld length, times 1000. And then heat input, it's a bit bigger just to get that all sorted, is the same equation, but what we're going to do is put this into another set of brackets and then times that by our thermal efficiency. So we have two very similar equations where we can work out both at the same time if we write our spreadsheet correctly. And in those equations, we've already identified what we need. So we need some volts, we need our amps, we need our time. And that time I'll put in seconds. We need a length, which we'll put in our millimeters. And that will give us our arc energy. And our units for that is kilojoules, so small k, big J, a millimeter. And get that sorted so it all looks right. And we can wrap that round and do it like that. Okay, so that's the bit. That's the first part of our spreadsheet, and I will just make this look nice because it'll just take us 2 seconds. And here we go. So what's our first part of our equation for arc energy? Well, that equals bracket, because of course we've identified we want to do this part of the equation first. So volts times amps times time. Put that in a closed bracket, and then we're going to divide that by our length times 1000. And we'll get an error here first because these sections are currently blank, and it's basically saying, well, I'm doing the equation and there's no answer. So if we just put some random numbers in, so let's say that by, I don't know, 140, we've welded for 45 seconds, we've got 40 millimeters. So that gives us an arc energy of 1.89 kilojoules a millimeter. Great, our first step. Now, arc energy is all right. It's not the equation we want for British Standard though. So for British Standard, we're going to need to work out the heat input. And again, that's going to be in kilojoules a millimeter. So a little bit of that. Now, in order to make arc energy across to heat input, we need a thermal efficiency of a process. And to get that thermal efficiency, we need the process itself. So I'm going to add in a new box here at the beginning, which is our process. Again, and just quickly get the formatting correct. So let's say our process is TIG. Well, I know the thermal efficiency for TIG welding is 0.6. So because we've now got a thermal efficiency, we can go heat input equals arc energy times our thermal efficiency. And that's going to give us 1.134. Now this is a few too many decimal places, so I'm just going to right click on that and go to number and make it to 2 decimal places only. You can go to whatever decimal place you want. I tend to work on on 2 all the time, because that is, it's a little bit more accurate, but it's not on the silly side of things. So here we have our arc energy and our heat input. Now, that's great, but every time I want to change my process, I might have to change my thermal efficiency. Do I want to be doing that all the time? Well, let's try and automate it a little bit. Now, to do that, what we can do here is I'm going to make a little box here, which is process and thermal efficiency. So I'm going to add in a few different welding processes. Looks core arc welding and saw. And I'll put in thermal efficiencies next to them. Now, thermal efficiencies, if you don't know, the easy way to remember this is TIG is 0.6, submerged is 1, and then the other arc welding processes are normally 0.8. So when in doubt, it just gives you a nice little sort of guess to try and have the best idea you're going to have. So to automate the process side, I'm going to go to data validation, and change this to allow a list. And then my source on my list is going to be these cells here. So we've got the cell locations down there. And now that's going to bring me up an auto select for my different things. But we want to make this thermal efficiency change as we change the welding processes. So a very simple equation for this would be equals VLOOKUP, and then an open bracket. And you can see here it starts giving you guidance about what you need to put in. The first one here is lookup value, where we want to look up this TIG statement here. So that's SIG10, put a comma in, and where do we want to look it up at? Well, I want to look at this array here. An array is just, a posh name for a table. So look in this table for this value. And when you find it in the first column, the answer you return, I want from the second column along. So I'm going to put a 2 in there. And then it's in, well, how do you want me to check for this? Well, if we check with false, that's only going to return an exact match. So if you put tag or something else in the list, it won't try and look at those values. It will only ever pick an exact match for our equation. So if I hit enter there, hopefully now when I change this, I get an automatic change there of the thermal efficiencies. Now you can add to the list as much as you want, as short as you want, any number, the same process applies. You just VLOOKUP, great tool. And of course that gives us the overall working of a calculator for arc energy and heat input. Now you can take this, you can wrap it up however you want. I have a slightly the same version, but it looks different within an ASRA data sheet. We'll be looking at that when we do welding procedure videos later on in November. But you can get started here and you can have a go and you can check. You add multiple lines in, maybe weld passes, all of that type of thing. But it means you don't have to work out the values every time. And with that, I've probably babbled on enough. So I hope that was of use. If you like it, please remember to hit the like button. And if you're not already subscribed, I hope I earned your subscription today. If not, keep an eye out for the next video and hopefully we'll get you next time. Good luck with your studies, everybody. Stay safe.